We are covering the fundamental differences between allowable stress design, or ASD, and load and resistance factor design, or LRFD, specifically for the FE Civil exam. This topic is critical because it represents two distinct philosophies for ensuring structural safety, and you will absolutely see questions that require you to apply one of these methods. Let's start with ASD. Think of ASD as the traditional method. Its core principle is that the actual stress on a member under service loads must not exceed an allowable stress. The equation is simple. Actual stress is less than or equal to allowable stress. The allowable stress is determined by taking the material's yield or ultimate strength and dividing it by a single, comprehensive factor of safety, represented by the Greek letter omega. For a steel tension member, this factor of safety is typically around 1.67. The loads used in ASD are unfactored service loads, like dead load plus live load. This is a key distinction. Now let's shift to LRFD, which is the more modern, probability-based approach. LRFD ensures that the factored resistance of a member is greater than or equal to the sum of factored loads. The equation is phi Rn is greater than or equal to the sum of gamma Q. Here, we have factors on both sides of the equation. On the resistance side, the nominal strength Rn is reduced by a resistance factor phi, which is always less than 1, and accounts for uncertainties in material properties and construction. For steel and tension, phi is typically 0.9. On the load side, the service loads Q are amplified by load factors gamma, which are usually greater than 1. These factors account for the variability and uncertainty of loads. For example, live loads are less predictable than dead loads, so they get a higher factor. A very common LRFD load combination you must know from the NCEES reference handbook is 1.2 times the dead load plus 1.6 times the live load. On the FE Civil exam, a typical question will provide service loads and ask you to find a required strength using one of these methods. For example, a tension member supports a 40 kip dead load and a 60 kip live load. The question asks for the required nominal tensile strength using LRFD. First, you calculate the factored load, which is 1.2 times 40 kips plus 1.6 times 60 kips, giving you 48 plus 96, for a total of 144 kips. This is your required factored strength. But the question asks for the nominal strength, so you must set this equal to phi Pn. The final step is to divide the factored load of 144 kips by the resistance factor, phi, of 0.9. This gives a required nominal strength of 160 kips. A common exam trap is to forget this final step and incorrectly choose an answer of 144 kips. Another trap is mixing the methods. Never apply LRFD load factors in an ASD problem. The exam will give you clues like allowable strength for ASD or factored resistance for LRFD. To help remember the difference, use this phrase: LRFD jacks up the loads and reins in the resistance. This mental shortcut reminds you that LRFD increases the loads with gamma factors and decreases the strength with phi factors, addressing uncertainty on both sides of the design equation. ASD, in contrast, uses service loads and applies a single factor of safety to the resistance side only. For free practice questions, AI-powered explanations, and more exam prep tools, visit openexamprep.com. That's openexamprep, all one word, .com.